Hello, everybody. My name is Alyssa Wroniak, and today I will be talking to you about the strontium organometallic complex of ZN2, SRL, OAC2 with a novel asymmetrical bisalmyl type ligand H5L. So our main focuses today will be on the background of salmon type ligands, the coordination chemistry between the H5L ligand and strontium, and the antimicrobial activity of the complex. We're going to first discuss the background of salin and salmon-type ligands so that we have a better understanding of the complex and the novelty of the H5L ligand that is synthesized and used for the first time within this complex that we are studying today. So salin and salmon-type ligands have been used in numerous fields of study, including catalysts, asymmetric synthesis, organometallics, and much more. They are also commonly used and studied in the field of photoluminescence. So salin has this basic structure. It is a carbon chain sandwiched between two nitrogen atoms, double bonded to carbon. Now, to modify this, if you add oxygen atoms to the salin ligand, you are able to get the salamo ligand, as seen in the structure below. So please note again that it is a carbon chain that is sandwiched between oxygen now first, and that oxygen is then bonded to the nitrogen, which is double bonded to the carbon. It is these symmetrical ligands that we were going to be focusing on today. Now, our main focus will be on the salamo ligands, and typically this has been studied in the form of an H4L ligand. Now, an H4L ligand is an acyclic bisalamo type ligand. It contains the N2O2 salmo motifs, which were just shown in the previous structure. I will go back for you guys to see again. Please note the N2O2 part of the salmo structure. And when that part of the structure is metallated, it can form an O6 cavity. Now, it is this cavity that is very unique and is why the H4L ligand has been used and studied in the past. So this O6 cavity is large enough to fit alkaline earth metals, such as strontium. It also has coordination sites within, meaning whatever ion that can fit within inside the cavity can coordinate within it, and is what actually gives its unique properties, such as allowing for its crystal structures, its magnetic properties, and fluorescence properties. Typically in this past, this ligand has been used to study fluorescence, photoluminescence, and things like that because it does have very good activity for that. However, a new ligand has been created and is what we will be studying today. And that is the H5L ligand. H5L is a asymmetrical bisalmo type ligand that is based off of the H4L ligand. So they are very similar in their properties. For this one also forms the O6 cavity and is why it is so unique. However, the H5L ligand has updated properties, better flexibilities, and it actually has been shown to have antimicrobial activity, which is why this is so unique and novel. Not only is it characterized for the first time, but it has been shown to be improved and has, again, that antimicrobial activity. So here you can see our structure. This is our complex that we've been gearing up to study. So this is the ZN2 SRL OAC2 complex with the H5L ligand. Here you can clearly see the strontium ion coordinating in between the O6 cavity. Please note that there's also two zinc ions that also are coordinating within. However, our main focus is going to be that strontium. Now, the coordination chemistry is of the complex. So the hydroxyl groups of the H5L coordinate with the strontium ion. Now, the strontium ion is octa-coordinated within the cavity and has a distorted square antiprism geometrical shape. Geometrical, sorry, stumbling on my words there. Meaning that it has a coordination number of 8 within it. Now, the ratio of the strontium to the ligand in the zinc is a 1-to-1 ratio. And both of the ZN or the zinc ion atoms have hexacoordinated with geometries that are distorted octahedral. So now that gives us a little more idea of the structure and how it is created and why it has some of those crystal structures. However, the main focus of this compound is the antimicrobial activity of the complex, which is what we will be discussing next. So a disk diffusion test was performed to compare the antimicrobial activities of our strontium complex, the H5L ligand, DMF, zinc acetate, and amoxicillin. Now, all these were done using staph for the gram-positive and E. coli as our gram-negative. Now, our amoxicillin is an actual antibiotic. So it was used as our control or our standard to compare our activity of how the strontium complex does. The H5 ligand was also added in there so that we can see if it had any activity itself, and that way we can determine if it was the newly synthesized ligand that is actually giving this complex its antimicrobial activity, or if it's just helping create it. So the results of this test actually show that the strontium organic metallic complex had was about 75% as effective as amoxicillin, which is a very astonishing and is a very good and proves that it does have actual microbial activity. Now, it is the Coulomb forces between the strontium ion and the ions in the cell membrane of the bacteria that cause the destruction of the structure. The H5L ligand also shows minor antimicrobial activity on its own, proving that it contributes to the antimicrobial activity. Therefore, it is the combination of the Coulomb forces and the newly synthesized, newly created ligand H5L that give this structure its total antimicrobial activity. Now, this is a very unique complex, and I'm just going to quickly review our main things. So the strontium organic metallic complex is of ZN2, SRLOAC2 with a asymmetrical bisalmyl type ligand H5L, which was newly created and synthesized in this complex. This complex has an O6 cavity that is suitable for the strontium metal ion. Now the O6 cavity is created from the Salamo ligands by metallating the N2O2 motifs of the Salamo type. Now, strontium has a coordination number of 8 within that O6 cavity, and this is because it has the octahedral shape. The coordination ratio of H5L ligand to strontium and to transition metal is a 1:1:2 ratio, meaning that for every one H5L ligand, there is one strontium, and for every one strontium, there are 2 zinc metals. And the complex has been proven to have antimicrobial activity. Now, it is this antimicrobial activity that is going to most likely be the focus for future development and use. Previous structures that had the H4L ligand did not show to have antimicrobial activity. Therefore, this new H5L ligand is probably going to be seen a lot in the future in use of antibiotics in the medical field, and will be further used and developed in the future. So that was my, thank you for listening to me today about my strontium organic metallic complex. I had a great time talking to you all today. I hope you have a good day. Thank you.